Okay, for today's agenda 1116, module 6, which is past due, is still open. So if you did not get into module 6 and do all the assignments for module 6, it's still open. The assignments will be past due, but you can still hand them in. And I'm going to go over in particular one assignment with you guys. And also write down that module 7 is open and due on Friday, 11/20. Module 7 only has 2 assignments in it. That's it, 2. Module 5 is closed. Remember, I reopened that for you guys for an extra 3 weeks. Module 5 is now closed. Get something to read. Okay, so I'm going to share my screen with you guys. And I am going to show you here. Let's go into, you guys are period 3. So we're going to go into period 3. And there are a few things that I want to go over with you today. First thing is the modules. So module 6, like I said, is past due now, but it's still open. So, and I know I went over this multiple times, but I apparently still need to go over it with some students, which is okay. But for those of you who have not yet completed module 6, and I'm going to tell you, last period, less than half the class handed in the vocabulary for module 6. The vocabulary is worth 60 points, guys. 60 points. And is very important for your quarter 2 grade. Okay, remember, we're starting over. Quarter 1 is not going to affect quarter 2. Your quarter 2 grade is, going to be based on module 5 on. Module 0, 1, 2, 3, 4 or from first quarter, they're not going to affect your second quarter grade. The module 6, sorry, the vocabulary assignment. I sent you guys an email on how to do this. In here, I've given you a PowerPoint, and we talked about it. There are 5 virtual flashcards that you need to fill in, and I've given you a 6th one with as an example, right, for the word atom. And you had to give me the definition, a picture, 3 things that an atom is, and 3 things that an atom is not. I've done that one for you. You're going to apply that same idea to protons, neutrons, electrons, atomic mass, and atomic number. Now, some of you did not know how to convert it to a Google slide, which is fine. See, only 18 people in period 3 have done this. What I did for you is if you go over here into your inbox, right? Everybody has a mailbox on Canvas. And you go into your inbox. I'm going to go to my sent emails where it says module 6. And this is yours. It went to everybody in period 3. See where it says period 3 here? It says when you are completing module 6.1b, you need to write in a PowerPoint. Some people are having trouble with this. I did not know the Chromebooks did not have PowerPoint. So you're going to do the following, right? It says open a new tab, So you can open a new tab. You can copy this link and put it in the new tab, which I like that idea better instead of doing it all through your Canvas account. So now you have it here, right? What I would like you to do, it says copy in the new tab, make a copy of this when it opens. So you're going to go to File, make a copy of the entire presentation, and click OK. This is the one that you will write on. Yes, it has Paige's name there. Paige helped me with this. But the rest of the document is blank. Okay, so what you're going to do is you're going to click where Paige's name is, and then you're going to erase her name and put your name, right? Then you're going to go down to the slide that says proton, and you can click in there and write the definition of a proton. A proton is a positively charged subatomic particle that is found in the nucleus of an atom. Good? And you're going to type in everything that you need to. For this picture, you could get it off of the internet. Then what you're going to do is you are going to share it, copy the link, right? And share it with me, submit it into your class, which is period 3. Wow, I don't know where I got periods. I guess because we're talking module 6. And you're going to submit it into that module. Okay, so module 6, that's open for you guys. Only 18 out of 30. 18 out of 34 students have done it. So that means another 16 of you still need to do it and hand it in. It's worth 60 points. Besides that, in module 6, like I said, you had a few quizzes to take. Besides the quizzes that you had to take, you also had to fill out information on reading an analogy. You don't have to fill information out on that, but reading an analogy for your assignment. Now we're in module 7. Module 7 has to do with molecules and bonding. We're going to be talking about covalent bonds and ionic bonds. There are 2 assignments in module 7, the covalent bond activity and the periodic table quiz. That is it. There's only 2 things to do in there. Okay. Do you guys have any questions about what it is that you need to do and what's expected of you? And if you don't, tell me that you're good in the chat. Max is good. Thank you. Anybody else there? Thank you, Ben. Okay. All right. Good. Good, Nathan. Okay, Fischetti. Thank you. Good, good, good. Okay, so the question came across about the 60 points. I'm going to talk to you guys. Yeah, I did this week, and next week is going to be easy also, Gavin. I'm not going to give you a lot. All right, hang on. Let me just review where the 60 points come from. This is an example of your flashcard, right? And I gave you atom. So there's the atom. Now you had 4 squares to fill in, or 4 rectangles to fill in. Each one, the definition the definition, the picture, 3 things that it is and 3 things that it is not, they're all worth 3 points. So if I have 4 rectangles on here worth 3 points each, 4 times 3 is 12. You get 12 points total for each flashcard. How many flashcards are there? There are 5. 12 times 5 is 60. So there's where the 60 points comes from, right? Let's say you put in 2 reasons or two things that a proton is and not 3 things. I can take off a point for that. If you leave out a picture, I'll take off 3 points for that. If you don't define it correctly, I could take off credit for that. Do you understand where the points come from now, Tasha? And anyone else? Good. Okay. And then the other ones are quizzes. So that's for you guys. Does anybody have any questions about what it is that you need to do and when it is due? Okay. Today we're going to talk about chemical bonds. So I need you guys to take out a piece of paper for notes. We're going to draw, but trust me, the drawing is easy. I cannot draw. I usually draw stick figures. So this is just drawing like kind of circles. It doesn't have to be circles. I am going to go over some math with you. So if you are not a fan of math, I don't want you to lose sleep over this math. It's okay. Good. I like math too. Usually math and science go together. If you're a science person, usually math is all right for you. Okay, so I want to talk to you about how bonds actually happen. Remember when I was talking about the periodic table of elements, right? And all these guys over here in our inert or noble gases, how I said to you guys that those guys, those elements that are in there, they're very stable. They're the ones at the party that don't need to interact with anybody else, right? Do you remember that? Thumbs up. Good. Okay. There are some elements that are reactive. There are some other elements that are highly reactive, where they really need to combine with other elements to become stable. The goal is to become stable like those inert or noble gases, right? In order for that to happen, it has to do with how many electrons there are in the electron shells, right? And I told you guys that surrounding the nucleus, you have a cloud of electrons. And in that cloud of electrons, there are different shells that surround the nucleus. So I'm going to ask you guys to look at the element sodium, which has an atomic number of 11, right? Look at the atomic mass and tell me, based on the information that I've given you and you're looking at it, tell me how many protons, how many neutrons, and how many electrons in a private chat. How many protons, how many neutrons, and how many electrons for the element sodium? For the element sodium, how many protons, how many neutrons, and how many electrons? Look at the atomic mass and the atomic number. Uh-oh, Tasha, can you look one up on the computer and split the screen? Oh, so close, Gavin. You've got a couple mixed up. Yes, Connor, very good. Try again, Gavin.
I didn't hear.
You didn't hear, Nathan?
No, I was.
Okay. I would like you to tell me how many protons, how many neutrons, and how many electrons for the element sodium.
Oh,
Evan,
okay. Sorry about that.
Evan, that's a great start. You've given me the atomic mass. You've given me the element symbol, which is actually incorrect. It's a capital N lowercase a. And you've given me the atomic number. I want you to tell me how many protons, how many neutrons, and how many electrons. Yes, Max. Yes, Gavin. That's correct, Evan. But again, try to focus on how many protons, how many neutrons, and how many electrons for the element sodium. You can look at your notes. You have notes. You should have written notes on the back of your sheet. Excellent, Layla. Yes, Nathan, very good. Richard, where are you? Maddie, Grace, Ricky, Fischetti, Moises, Sophia, Grace, Kaden, I know you know this, Morgan, Uretzi. Good, Maddie A. Good, Arnaldo. Oh, did somebody not put it in private? Oh, Nathan. Oh, Nathan gave it away to everyone. Yeah. Okay. So since it went out to everyone, the atomic number gives us how many protons there are, right? Protons are positive. The atomic number says that there are 11 protons. Stop, guys. The atomic mass is 22.99. We're going to take that number and we're going to round it. So the atomic mass for sodium then becomes, if it's 22.99, we're going to round the atomic mass to be 23. Now, if you look at the notes that I've given you, the mass is how many protons and neutrons are in the nucleus. So we've talked about it and we said, well, imagine that protons are purple, right? We're talking about Skittles because you guys like candy. In the bowl, which would be our nucleus, in that bowl, I have 11 purple Skittles. All together, I have 23 Skittles because in that bowl, in the nucleus, is all of my protons and neutrons. But I know that I have 11 purple ones. And we said, okay, well, let's think about neutrons being red because we have red and purple Skittles. If all together in the bowl, I have 23 and 11 of them are purple, how many of them are red? So you're going to take 23, the number 23, and subtract 11, and you get 12. So there are 12 neutrons and 11 protons. Our protons and our electrons always have equal numbers because we want the atom itself to not be electrically charged. So if I have 11 positives, I need 11 negatives, right? So that means that it has 11 electrons. So the first thing I like you to do with your drawing is to draw a nucleus. And in that nucleus, I would like you to write protons. Now I put a proton, I put a P positive because protons are positive. There are 11 protons. And in the same nucleus for sodium, the neutrons are neutral, so I put a little 0. Oh, you can't see? Can you see it now? I put a little 0, so in the nucleus, I put neutrons at 12. Okay? So draw a little nucleus for your sodium atom. And I also put over here sodium. The atomic mass is 23. Good. Good, Nathan. Okay. So now we're going to talk about the electrons, right? And we said that if there are 11 protons, there are 11 electrons. That's okay, Audrey. If there are 11 protons, there are 11 electrons. Now, electrons, I said to you already, if you have the nucleus, the electrons are surrounding the nucleus in what we call the electron cloud, right? So don't draw, we're going to take a couple of notes over here. The electrons are found in the electron cloud that surrounds the nucleus of the atom. Right, so I typed electron cloud in capital letters because it's one of the vocabulary words that you should know. Electrons are found in the electron cloud. The electron cloud is on the outside of the nucleus. And when we draw the electrons on the outside of the nucleus, we actually draw them in rings around the nucleus. Those rings are called, all right, so we'll say they, electrons are drawn in rings around the nucleus. Those rings are called shells. Okay, so now we have outside of the nucleus, we have the electron cloud, and in the electron cloud are shells where our electrons go. Now, it's not like I have just one shell with electrons shoved into that shell. It's not how it is. Each shell can hold a certain amount of electrons. The first shell, the shell closest to the nucleus is called, let's do this, shell K. Okay. Shell K is the first shell around the outside of the nucleus. And I said they're drawn as rings. So here's an example. There's my nucleus, right? And I drew one shell around the nucleus of the atom. And that is shell K. Shell K can only hold 2 electrons, and that's it. It's full when it has 2 electrons in it. So I'm going to draw my 2 electrons for shell K. Just 2 dots filled in, right? So there's my nucleus. Surrounding the nucleus is shell K. Shell K has 2 electrons. But sodium, we said, has 11 electrons. So that means we're going to need to add more shells to add those electrons. I'm going to give you a formula for figuring out how many electrons can fit into the shell. Okay, here's the formula right there. 2n squared. N squared is in parentheses, so it's going to indicate multiplication, right? So what I did for shell K Shell K is the first shell. Remember, it's the first shell outside of that nucleus. So I did 2 times 1 squared because the first shell is indicated as 1. 2 times 1 squared. 1 squared is 1 times 1. 1 times 1 is 1. So 2 times 1 equals 2, which means that shell K can only hold 2 electrons. Okay. After shell K, the next shell that you can draw around shell K, like that, is shell L. Second electron shell is called shell L. Now, if I were to take the same formula shell L is the second shell, right? So 2 times 2 squared. 2 squared is 2 times 2, so that's 4. And then 2 times 4 is 8. So that means that I can fit 8 electrons in that second shell, shell L. So I'm going to draw my electrons in that second shell. And what I do to evenly distribute those electrons, I draw north, south, west, east, and then my 4 corners. Okay, so there's 8 in that second shell, shell L. Now, if the first shell is shell K and the second shell is shell L, what do you think the third shell is called? Yes, Maria, I can see, I could read lips. Yes, it's M, good. So we're gonna have shell M. Take the same formula and tell me how many electrons can fit in shell M, which is going to be our third shell around the nucleus. Take the same formula that I've given you. Try again, Nathan, sorry, try again. Remember, it's the third shell. So because it's the third shell, let me type something in the chat for you guys. It's the third shell, right? So it's going to be 3 squared in the parentheses. Yes, Nathan. Yes, Max. The first shell was 1 squared. The second shell was 2 squared. The third shell is 3 squared. The fourth shell would be 4 squared, right? Yes, gotta love math. And it's very sequential, the way that this is done. Gavin, 3 times 3 times 2. Try again. 3 times 3 is in the parentheses. So 3 times 3 is 9, and then 9 times 2 is 18. So the third shell could fit 18 electrons. Nope, 3 times 3. Yeah. It's okay, Audrey. I'm recording this, so whatever you miss, you can go back and watch on my YouTube channel, right? It's okay, Gavin. It's okay. We all make mistakes. Okay. So now if I go back and I look at my sodium atom, right? It says that I have 11 protons, which means that I have 11 electrons. What I've done is in my first shell, I put 2 because that's all that can fit in the first shell. In the second shell, I put 8 because that's all that can fit in the second shell. 8 plus 2 is 10. But sodium has 11. Can I fit 1 electron in shell M? Sure. Shell M can take 18 electrons, right? So I'm going to put my 1 electron in shell M. So now if you count all of my green dots, which are my electrons, you'll count that I have 11 electrons there. 2 in the first shell, 8 in the second shell, 1 in the third shell. 2 plus 8 is 10, 1 is 11. The thing is that shell M can hold 18 electrons, which means it has a lot of room to get those electrons, which means that it's not very full, right? Now, if you look at the elements that are in the inert gas group, those outermost shells are completely full. They are very stable. That's what I was saying to you when I said that they're very stable atoms. They're very stable because their outermost electron shell is full. It doesn't need to gain electrons to fill it. It doesn't need to give away electrons to fill it. It's very stable. And I said the ones all the way in group 1 are highly reactive. The reason why they're highly reactive is because their outermost shell has 1 electron. So they either need to gain a whole bunch of electrons to become stable or lose electrons to become stable. Well, if I'm looking at this one, sodium, is sodium better off gaining 17 electrons, or is it better off giving one of those electrons away? Which would be easier? Would it be easier to gain 17, or would it be easier to give 1 away? Yeah. What does it want to do? Does it want to gain 17 electrons, or does it want to give 1 away? Tell me in the chat, guys, so I know that you're listening to me. Yes, Tasha. But tell me in the chat, do I want to? Yeah, Evan, good. Is it easier to gain 17, or is it easier to give 1 away? I'm waiting to hear from you guys. I want to know that you're there. Connor, Gavin, Maddie C, Moises, Ben, Richard, Andrew, Sophia Grace. Yeah. Yeah, it's going to want to give 1 away. So when it gives that 1 electron away, it becomes now a positively charged atom. Because if it's giving one of its negatives away, now it's only going to have 10 negatives, but it's still going to have 11 positives in the nucleus. So it's a positively charged atom. When an atom gives an electron away, we call that an ionic bond because you're making an ion. So when an atom gives an electron away, it is an ionic bond. Sodium, Na likes to combine with Cl. NaCl is something that a lot of people may have too much in their diet. It's salt. Na really likes to give its electron away to chlorine, because if you were to look at chlorine, chlorine has 17 electrons, right? It has 17 protons, so therefore it has 17 electrons. In order to be stable or more stable, it's going to take in that electron from Na. Na is going to give its electron to chlorine, and chlorine, NaCl, is going to be created, and it's going to be more stable. Does that make a little bit of sense to you guys? Okay. So I'm going to end this here because we talked about ionic bonding. I